I am Dr. Downs, and I work with the RL-10 rocket engine at Pratt & Whitney for all of the upper stage rockets that go to space. And so what you see here is a model with the cutouts of the RL-10. This is called the Mae West. So this is the nozzle, and the Mae West is the whole part right here where you can see the cutout from the top here, the Mae West, which is the waist, all the way to the nozzle. So they call that the Mae West. Here is the transducer box. This is the pre-start solenoid, so when they kick off the rocket engine, which has the injectors, which put the fuel from the hydrogen and the oxygen mix, this is the solenoid that starts and kicks it off. Here is the turbo pump. So one of the main things with the engine is the turbo pump, which is back here, and that actually collects the fuel and swirls it in the right position where it's injected into the injector, which goes into the nozzle. So when you look at this rocket here is one of the main workhorses for NASA, for a lot of the upper stage payloads that go into space. So it does have a limit of burn based on how much fuel is there. So let's just say Perseverance going to Mars, they actually fired this rocket engine to get the speed of escape velocity to go to Mars, and once it reached that speed, this engine shuts off. So the engine perhaps is not used in the flight, but they have small thrusters that give correction to the flight based on the spacecraft as it's heading to its destination. So this engine itself costs, I would say, in the neighborhood of $5 million. It takes a long time to build this engine. So when you look at the parts here, the little streamers that are going down, all of these, you can see the hole that is cut out. The hydrogen is coming through these holes. The hydrogen and oxygen mix is coming through all of these holes. The reason why they put that through the nozzle is to cool the nozzle off, and the nozzle actually freezes over because the fluid that is supercooled, the oxygen and hydrogen that is supercooled, is at a minus 200 degrees, estimating somewhere in that area. And when it reaches the surface, it freezes. But interestingly enough, when this engine is fired, the coating on here is coated with ice. And so there's this heat and ice and constant freezing and melting. And so when you look at the nozzle, when the spacecraft is moving, you'll see water droplets coming out the end because the whole engine is producing hydrogen, which is a molecule with oxygen. And so when you have the hydrogen and oxygen mix, you have H2O. And so you will see the water forming on this as the two elements come together as one. So this is an amazing engine. The engineers that put this together, all the parts, every piece on this engine is very specific. If any part of this engine is not working properly, this engine could blow. So everything has to work. If we have the nozzle here, and this little nozzle has a fracture in the nozzle, it will blow the engine. It will cause a fissure and a blow. So all of these pieces are put together one piece at a time. There's no automation. Every part of this engine is put together by hand. And so when they are torquing it, it has a certain strength of torque for each bolt and nut, and it has to be exact. Every piece on here has to be exact, and it has to be signed off. So once I do this, I mark it and I sign it off on my sheet. and make sure every part of this engine is built right. That's why we've had very few RL-10 rocket engines, if any, of the latest engines that were built that have ever had a catastrophic failure. So these are very reliable, and now going to the moon, they're going to use this engine called the CECE, cryogenic engine, and it's going to have the capability to do 10% to 100% thrust ratio so that it can change its speed in the ascent and the descent. So just say it wants to go from this spot to another spot, they can treat it like a helicopter and increase the thrust and decrease the thrust. And that's the new cryogenic 10% to 100% thrust engine. So these engines are phenomenal. And they take this engine and they change it to different formats for the particular mission that they're going to use. And so I've given you a good spill of the RL-10 rocket engine. If you want to know more, there's more information on YouTube. And of course, you can always go to nasa.gov.